Welcome back to my channel. Today I am going to discuss about valence shell electron pair repulsion theory, that is VSEPR theory. So with the help of VSEPR theory we can find the shape of molecule and the angle between the molecules. Okay, that is completely depends on the valence electron present on us present surrounding the central atom. So according to VSEPR theory, so here the name itself indicating valence shell electron pair repulsion theory. So it is based on the number of valence electrons is surrounded by the central atom and how the repulsion occurs. So here let us consider the postulates of VSEPR theory. The first one, the shape of molecule or ion depends on the number and nature of electron pairs surrounding central atom in a molecule or a ion. Okay, here a shape of molecule, it is completely depends on the number and nature of electron pairs surrounding central atom. Okay, here number and nature of electron pair, that is we know that the valency of a particular atom, the nature, that is nothing but whether it has a lone pair electrons or a bond pair electrons. Consider an atom A. Okay, so if it has a valency 4, so if it has a valency 4 which share here 1, 2, 3, 4. The 2 electrons involved in a bond and the 2 electrons remains as a lone pair. Here if the electrons involved in the formation of a bond, then it is called bond pair electrons. Okay, so that is bond pair electrons. Similarly, if the electron doesn't involve in a bonding, then it is considered as lone pair electrons. Okay, so in a periodic table we know that group 1, group 2, 13, 14, 15, 16 and 17 group. So in the group 1, the valency of a group 1 element is 1. Okay, you can take any element present in a group 1, that is alkali metals, the valency which shows it has a 1. So it may be lithium, sodium, potassium, rubidium, whatever. So the valency is 1. Similarly group 2. So in the group 2 elements, so these beryllium, magnesium, calcium, strontium, all these possess a valency 2. Okay. Similarly group 13, the boron family have the valency 3. Then group 14, the carbon, all the elements present in a carbon family possess the valency 4. Similarly in a group 15, that is a nitrogen, it has a 5 valency. Group 16, that is oxygen or a chalcogen, so which possess the valency 6. Similarly group 17, it has a 7 valency. So here what is that valency? The ability to form a bond with the other atoms. So in the boron family, the boron can minimum, it can form a 3 bonds with the other surrounding atoms, right? So the next postulate is the magnitude of repulsion between bond pairs electron depends on a electronegativity difference between the central atom and the other atoms. Okay, here the repulsion occurs between a lone pair and bond pair electrons, that is depends on the electronegativity difference. Okay, so we know that this NF3 and NH3. Okay, so the repulsion more occurs at NF3 and the bond angle reduces to 109 degree 28 minute to 104 degree 48 minute. So here if the repulsion occurs which reduces the bond angle as well as which distort the shape of a molecule. Okay, so the next point, the geometry of molecule is distorted due to presence of lone pair of electrons. Okay, as already I have said. So if there is a number of lone pair electrons present in a molecule, which means which distort the shape of molecules by reducing the bond angle. If only bond pair of electrons is present, the molecule has regular shape. Okay, if a molecule has only bond pair electrons, so it has a regular shape as well as the regular bond angle. For example, we know the valency of a carbon, so which possess a valency 4, means which can form a bond, 4 bonds with the other atoms. Okay, the bond angle will be 109 degree 28 minute. Okay, it has a regular shape, that is a tetrahedron. So if either CH3, okay, so here the carbon possesses 3 bond pair and 1 lone pair electron. Okay, comparing to the CH4, so the angle will be reduced in the CH3 as well as the shape will be distorted. Right, as the lone pair of electrons increases, the electrostatic repulsion increases. The deviation from a regular shape also increases. Okay, here if the molecule, that is the molecule have more number of lone pair of electrons, so that the lone pair of electron increases, the electrostatic repulsion also increases. Okay, here the deviation from the regular shape also increases, means the shape of molecule will be distorted here. Then the order of repulsion is lone pair is more means there is a more repulsion occurs between lone pair electrons than the lone pair bond pair. Okay, the repulsion occurs less comparing to this lone pair. Again, if the molecule have bond pair electrons, again it suffer lesser repulsion than this lone pair and bond pair, and the bond angle decreases due to the repulsion. As the more number of lone pair electrons present in a molecule, which has a decreases in a bond angle as well as the shape will be reduces or distorted. Okay, this is what the postulates of an VACPR theory. So let us solve some examples based on this VACPR theory. Okay, let us consider the shape of boron trifluoride, that is BF3. Here the boron atom is a central atom. We know that the valency of boron is 3. Okay, so it is surrounded by the 3 fluorine atoms. We know that the valency of a fluorine is 7. Okay, so here the boron which share 1 electron to the other atom, so formation of a covalent bond. So we know that the definition of covalent bond is the mutual sharing of electrons between the two atoms. Okay, so then there is a formation of a bond between the two atoms, that is called a covalent bond. Correct, this is what covalent bond formed between the boron and this fluorine. So you have to remember one thing, don't get confused. You have to consider the valency of only a central atom. Okay, it doesn't matter. Yeah, that is fluorine. We are not consider this the valence of an fluorine. That means it is not included in bond pair and lone pair. Only we have to consider the central atom, that is the boron. So here the valency is 3 which share 3 electrons to form a bond between other atoms. Okay, so it is clear here. There is no lone pair electrons, there is only bond pair electrons present in a this boron. Okay, so here the bond angle will be 120 degree. So the shape of molecule is a planar triangle. So the here the central metal having all the 3 bond pair electrons, so which suffer very less repulsion among these electrons, so that there is no any repulsion occurs, so that it has a regular shape as well as a regular bond angle. Okay, hope you understood. Okay, let us consider another example, ammonia. Here the nitrogen which is surrounded by the 3 hydrogen atoms. Okay, here the nitrogen is belongs to what? The 15th group. The valency of nitrogen is 5, right? So there are 3 hydrogen atoms. Okay, so we know that a dot structure. Okay, this is what nitrogen. Yes, now the 3 hydrogen atoms are surrounded by the nitrogen, okay, which share 1 electron to form a bond between the nitrogen and hydrogen. Yes, okay, here the nitrogen central atom, it has a valency 5 and the 3 electrons are involved in a bonding the one pair which left as a lone pair electrons. Okay, so there is a repulsion occurs between the lone pair and bond pair. So we can write the structure like this. Okay, so here it has a regular tetrahedron shape, but the angle, the 3 hydrogen atoms are as well as the one lone pair which occupy the corner of the fourth position of a tetrahedron, so that so it is considered as the either pyramidal or you can say a tetrahedral structure. So the bond angle will be reduces to 107 degree 48 minute. Okay, due to the presence of one lone pair electron, as we know that in a tetrahedron, that is 109 degree 28 minute, it is the bond angle in tetrahedral geometry. But due to the presence of one lone pair, how it is here, the valency of the central atom nitrogen is 5, the 3 electrons are involved in a formation of a bonding and the 2 electrons remains as a lone pair electron, so that this NH3 molecule has one lone pair and one bond pair electrons, so that which suffer a repulsion among these electrons and which distort a shape of molecule as well as reduces the bond angle 107 degree 48 minute. Okay, hope you understand the formation or explanation of the shape of a different molecule based on a VS-EPR theory. Simply in a VS-EPR theory, we must know this valency and we have to remember easily. That is, if you know the group 1 elements, all the group 1 elements have one valency and group 2 elements has the valency 2. Similarly, group 3 has a 13 group, and 14th group has 4. Similarly, 15th 5, 16th 6, and 17th group has a 7th valency. So that you must know the elements of all these groups. Then if you can easily solve the examples based on a VSEPR theory. Okay, thank you.